Homework 1.7, Inequalities, Video 8. Homework due Saturday, May 16th, 2020, 11:59 p.m. Absolute Value Inequalities, Part 2. This is the last video in this series, and this series represents the last homework that's on your second test. So upon the conclusion of this homework assignment, if the test one is already available, and it will be available on Thursday, May the 14th, you should prepare for and take that test as soon as possible. It will be open until midnight, Saturday, May 16th. All right, let's take a look at one more absolute value inequality and show you how sometimes when things go bad, things actually go good. It's all a matter of perspective. So let's solve the absolute value of 3x minus 5, and then plus 7 is greater than or equal to 4. Step 1, change it to equals and solve. So let's rewrite the inequality except as an equation. And now let's solve it. And again, if you've forgotten how to solve absolute value equations, I refer you to Module 5, videos 7 and 8, absolute value equations, part 1 and 2. All right, and if you look in those, it will say the first thing you need to do is isolate the absolute value. So we need to get rid of the 7, which is added, so let's subtract it. And we get the absolute value of 3x minus 5 on the left, and on the right we get negative 3. 4 minus 7 is negative 3. Is that good or bad? Well, it's bad if you don't catch the next move. It's good if you do. Can we continue solving? You can, but your answers will be wrong. Because part of the absolute value equation videos in Module 5, videos 7 and 8, say that if this number is negative, there is no solution. Which, if you think about it, makes sense, because absolute value measures a distance, and distance never comes out negative. So at this point, this equation has no solution. But we're not solving an equation, we're solving an inequality. So what does that mean about the rest of this flow? Well, the second step is to partition the number line of the solutions that we got. So what would happen if we do a number line and did not partition it at all? How many intervals would we have? Well, we start with one giant interval, the entire number line. And if we had solutions, we would cut it into more intervals. But if there is no solutions, that means you don't partition. Which means you take the number line as one single interval. Again, if we had solutions, we would go chop, chop, and have, in this case, 3 intervals or 4. Or if we only had one solution, we would only partition it once and cut it into 2 intervals. But if there's no solution to the equation, then there are no partition points. So our original number line remains intact. And then we keep going. Select one test value from each interval. Well, there is only one interval. So when you need only one test value, give me a number between negative infinity and infinity. 0. We're going to test x equals 0 from the only interval we have to select from, namely the entire number line. So if we test 0, we get the absolute value of 3 times 0 minus 5, all that is in the absolute value, plus 7 is greater than or equal to 4. 3 times 0 is 0. 0 minus 5 is negative 5, so let's go ahead and call this the absolute value of negative 5. Plus 7 is greater than or equal to 4. The absolute value of 5 is 5, and at this point, I really don't need to add the 5 plus 7. I know that's going to be greater than 4. I know this is true. So what does that mean? That means the one interval we have is a keeper. So our answer is that one interval, negative infinity to infinity. All real numbers, this is always true. What would happen if it had said less than? If it had said less than, this still would have been equals. We still would have gotten no solution. We still would not have partitioned. We still would have had one interval. We still would have picked one test value, and we would have tested it in the original inequality. But had this said less than, This would have said less than. This would have been false. We would have crossed out the only interval we had, and the solution would have been no solution. So there is something to do when you're solving an equation and you do not get a partition value. That just means you test the entire number line with one single test value. And that wraps up this series of videos. That wraps up the material that is on test 1. So homework 1.4, 1.5, 1.6, and 1.7. In terms of modules, modules 2, 4, 5, and 6. Remember, module 3 was a factoring review. It was optional. There was not a homework assignment associated with it. But if your factoring skills need polishing, I strongly recommend watching the videos in it. If you need some more assistance with factoring, let me know. I've got some notes that I can supplement. In fact, I may upload them to Canvas and just post an announcement and say, hey, here's everything you could possibly need to know about factoring in this class. All right, you know how to get a hold of me. Some of you have already started and finished the first homework assignment and started the second one. That's great. This homework assignment, according to the calendar in the syllabus, is scheduled for Wednesday, May the 13th. So if you are watching this prior to May the 13th and haven't started it yet, that's okay. If you are watching this after May the 13th and haven't started this assignment yet, you're behind. So if you're watching it on May 13th and doing the assignment, you're right where you need to be to keep a steady pace throughout the entire semester. All right, you know how to get a hold of me if you have any questions. Good luck.